Hello and welcome to helpyourmath.com. In this video, we are going to look at adding and subtracting radical expressions. To be able to combine radical expressions, we have to have what are called like radical expressions. Like radical expressions, you might have heard this before as like fractions, are expressions with the same radicand and the same index. So same radicand and the same index. That's the only way we can combine them. Are the following expressions like radical expressions or not? First, we have 2 radical 4 and 4 radical 2. So same radicand. This has a radicand of 4. Oh, no, that's no good. They do have the same index, but it had to meet both requirements. So no, these are not like radical expressions, which I'm just going to abbreviate and say not like radicals. Wah, wah. What about letter B? We have 5 times the cubed root of 6 and negative cubed root of 6. We're looking for the same radicand of 6, and the same index. Index of 3. Looks good. We do have like radicals. Yay! Okay, what about this one? 7 root 3 and 7 cube root of 3. We do have the same radicand of 3. However, this one has an index of 2 and this one has an index of 3. So these would not be like radicals. Right? It has to meet both requirements. All right, now that you are a pro at identifying like radical expressions or not, let's get into actually adding or subtracting if we can. So here we have, square root, 7, 7. So what we do is we almost treat the radical like it's a variable. And so what we're really looking to combine are the coefficients. So we're looking for 3 minus 8. It's like I had 3 radical 7s and I'm taking away 8 of them. Whoops, that leaves me with a deficit. I end up with negative 5 radical 7, and this would be my final answer. Notice that radical, just like if this was a variable, doesn't change. We just are combining the coefficients when we add or subtract. How about this second example? We have 5b root a, 3b root a. So this is kind of like the variable piece. Those should match and if we're going to be able to combine them, and they do. So we're looking at 5 plus 3. We have a total of 8 b radical a's in this second example. For the third example, I want to combine this 5th root of 3b and the 3rd root of 3b, but wait a minute. The indices don't match. We can't combine these. So I'm going to say cannot be combined. There's nothing we can do, or we can say cannot be simplified, but we can't combine those because they're not like radicals. For this next example, you might think to yourself, whoa, I already can tell the radicands don't match, which you're partially right and partially wrong because actually 2 do match, right? The first one and the last one do match. Now the question is, what about the middle one? It doesn't currently match, but can we simplify the cubed root of 32? And maybe if we do, we would have a 4 left over. So that's a strategy we can use. I know that in order to be able to combine this with the other 2 radical expressions, that I would have to have a 4 left under the radical. So does 4 times some mystery number? Is that mystery number a perfect cube? 32 would be, so I'm just going to bring this middle term down. That would be 4 times 8. And 8 is a perfect cube. It is 2 cubed. So we can simplify this. So this becomes the cubed root of 8 becomes a 2. The 2 will join the negative 11 coefficient that's already there, and it becomes negative 22, since 11 times 2 is 22. And then stuck under the radical is that cubed root of 4, which now we actually can combine all 3 of these. So we're looking at the coefficients 6 and minus 22 and positive 7. And then we have the cubed root of 4. And so this would be 13 minus 22. We would end up with minus 9 times the cubed root of 4. And that would be it. That's how we would simplify this one. These have been examples of combining, adding, or subtracting like radical expressions. Thank you for stopping by.